In a single sentence, IRSA is about getting access into AWS as federated IAM principles. So if we break that down into more manageable pieces, step number 1 would be to establish trust between AWS and Kubernetes, and step 2 would be configuring Kubernetes, where anytime a service account that is mapped to an IAM role is used on a pod, that pod is injected with proper environment variables. And the last step, step 3, being mapping the actual service account into IAM roles. So the provider is now registered. This was just step 1. We have 2 more steps to go through to get an actual IRSA deployment. Alright, so with that step done, let's go into step 2. Step 2 is actually getting Kubernetes configured so that it would inject correct environment variables into a pod so we could trigger certain credentials loading scenarios and establish that trust between AWS and Kubernetes. Now in the last video, I talked about the AWS SDK credentials loading chain. We talked about how the presence of certain environment variables triggers certain credentials providers in that chain. In EKS Pod Identities, the presence of the credentials server URL and the token file triggered the container credentials provider. In IRSA, we are going to trigger the assume role with web identities provider by using different kinds of environment variables. So the assume role with web identity provider looks for 2 environment variables. One is AWS role ARN, which should point to a valid role ARN. And the next one is AWS web identity token file, which should point to a file that contains a valid token that can be provided to AWS STS when the assume role with web identity operation goes through. For different pods, we can inject these environment variables manually. Now the role ARN can be derived from anywhere. We basically have to create a role in AWS to get the role ARN. The web identity token file should be a mounted file inside the pod that should contain the service account projected token. So if you don't know a lot about projected token volumes, they are basically a way to get short-term JWTs for the service account attached to a pod. So we could inject these environment variables, the role ARN and the web identity token file, manually to each pod, but this would not be the correct way when it comes to mapping roles to the workloads running in Kubernetes. The correct mapping would be assigning a role to an identity inside Kubernetes, and in Kubernetes, the identities for machines or service users would be service accounts. So we should be mapping a role to a service account, not a role to a pod. So the best way to get this done is to use something that we have already used in the previous video, which is called the EKS Pod Identity Webhook. Now, despite its name, EKS Pod Identity Webhook can be used for this scenario as well. It's not only for EKS Pod Identities. In fact, EKS Pod Identity Webhook was actually used in IRSA before EKS Pod Identities was released as a feature. At the core, this webhook is a mutating webhook that could inject different types of environment variables and mount service account tokens into pods based on different kinds of configuration. So in EKS Pod Identities, it would inject the environment variables needed for container credentials scenario if there was a configuration file specified with a service account to role mapping. In IRSA, what we have to do is to not specify that file so that the pod identity webhook would inject the 2 environment variables that we need for assume role with web identity provider. So in the last video in EKS Pod Identities, I just had to click on a checkbox so that it would install the pod identity webhook and the pod identity server into the cluster. But since in this demo, the Kubernetes cluster is outside of AWS, I'm going to have to manually install the pod identity webhook into the cluster. The installation instructions for this webhook are pretty straightforward. You just have to install a tool called Cert Manager, which will take care of generating and signing certificates needed in TLS and MTLS scenarios, and then install the pod identity webhook configured in a certain way. So the first thing I'm going to do is to install the Cert Manager, and this is a matter of copying this line and then running it on the Kubernetes cluster. So the Cert Manager pods have come online and they are running for some time. So Cert Manager is up. I'm going to clone the repository for pod identity webhook and modify certain files so that I can have it running with my configuration. So the artifacts that I need to use to deploy the pod identity webhook are inside this directory called deploy, but these are not really ready to be deployed by themselves. There are some details that needs to be changed before deploying these artifacts. Now the first is the image for this webhook, which is inside deployment base. So I'm going to open that file. If I go down into the container image, I can see the value here is a dummy value. So the value I'm going to copy in points to the Amazon released pod identity webhook image on the public Docker registry. And the next value that I'm going to change here is the default value that would be used for the audience claim if no value has been provided at the request time. Now we have set this default value to AWS STS on the API server side. That means any service account token that would be generated without a specific audience specified at the request time would have the value AWS STS in the audience claim. Now this place is one such case where you could override that value for all tokens mounted by the pod identity webhook into pods. But in this case, I'm just going to override that by the same value that I used in the API server. So these are the changes that I needed done in these files. So I'm going to save these and deploy these artifacts into the Kubernetes cluster. Again, the changes that I did are these. I replaced the image value. I changed the audience value that would be used on the tokens generated in the pod identity webhook. So I'm going to first create the roles and role bindings and cluster role bindings needed by the pod identity webhook. And then I'm going to deploy the actual webhook pod itself. And I'm going to create a service for this pod. And then I'm going to register this service as the mutating webhook to be used on pod creation. Right, so if we check the pods running on the default namespace, we can see that the pod identity webhook has been running for some time. Yes, they are by default deployed into the default namespace. I didn't make any changes to move them into a specific namespace because those could be a little bit overwhelming. But I'll follow this video up with a smaller video that would show you how to deploy the pod identity webhook on a specific namespace. So the pod identity webhook is running, and just to make sure that everything is running smoothly, I'll just check the logs and it's listening on the correct ports. So now that the pod identity webhook is up and running, it would get called every time there is a pod creation request because we configured the mutating webhook to call this endpoint for that specific event. So if I check the mutating webhook configuration, I can see that this service gets invoked every time there is a pod creation request at the API server. So if we go back into the architecture diagram, what happens every time there is a pod creation request is that request would get routed through the pod identity webhook, and it will check if there is a service account attached to the pod, and if there is one, it will check the service account to see if there's a role mapping attached to that service account definition for it to use as the AWS role ARN value. If none of these conditions are there, it will just let go and let the pod creation to continue. But if these conditions are satisfied, then it will create a service account projected volume token and mount it into the pod, and then attach those two environment variables, AWS role ARN and AWS web identity token file, into the pod. So at this point, we have completed step 2, where we configured Kubernetes to inject environment variables in a scalable manner into pods so that those pods will be able to use the assumed role with web identity provider in the credentials loading chain. Alright, so this is a good place to wrap this video up. Please keep a lookout on the channel for the other videos. If this content was helpful, please like the video. If you haven't subscribed already, please subscribe. That interaction helps the channel a lot. And also you'll be getting notified when other videos come out. That's it for me for now. Thank you so much for watching. I'll see you in the next video.